and transducer. Let's have a review about the last class. Transducer. This definition about the transducer and sensor. Sensor. You can for the difference. As the classifications about the transducer sensors classification and sensor type signal characteristic power supply model of operation subject of measurement is the classification. Sensor types analog, digital, active, passive, non-type, deflect type. Is the subject of measurement acoustic, biological, chemical, electrical, mechanical, optical, radiation, thermal, and others. As the element of instrumentation systems, instrumentation systems, the media is key material. In the material, the medium sensor the phenomenon, sense with the sensing module, then conversion module to the appropriate signals. After the manipulation, the data is sent to display. It's the element of instrumentation systems. Sensors type, position, velocity, acceleration, proximity, node and pressure, temperature, flow sensor, and liquid level sensor. Position sensor is potentiometer. POT is the abbreviation. As the features and the applications. Linear potentiometers are often considered when an electrical signal proportional to displacement is required, but also where cost should be kept low and high accuracy. Cost low and high accuracy is critical. Not critical.
Please, we can't see the PPT. You didn't share the page, please.
What?
We can't see the PPT. You didn't share the page.
You cannot see the PPT?
Yes.
Just wait a minute. Sorry. Let's continue. This potentiometer features and application. Cost is not critical, and cost is known, but the accuracy is not critical, which means potentiometer the cost is known, but the accuracy is not enough. Is not enough high. This is the features. This is LVDT linear variable displacement transformer. Linear variable displays transformer. Primary coin and then the secondary coins secondary coins and the secondary two coins when the shaft move to left and right, and the output is different. Output is different. This is the interface circuit. Phase sensitive rectify. Sensitive rectifies. And this is oscillation. Reference oscillation. Reference oscillation. Signal from the rectifies to the filter. The rectifies changes the current from alternative current to direct current, just like here, to direct current. After the signal is filled, the amplifies the signal, and the output to the some instrumentation or some device, LVDT features and application. High resolution, high accuracy, and high accuracy. Good stability. As the features about the LVDT. Features about the LVDT. Optical encoder. Optical encoding is categorized the two types about absolute optical encoding and incremental. This is the absolute. This is a different color, which means the white color is Hall, maybe the black color is solid. This is the incremental. The absolute encoder only one light source, and through the snot to the photo cell. Incremental encoder, two lines. One is for the reference sensor. One is for a reference sensor. Another is a position sensor. When the encoder turn different around, CC is counterclockwise. Counterclockwise. This is the signal. This is the signal. When the encoder turn clockwise, this is the output. This is the output. We can see the difference. Here is the difference. This is the V1 and the V2 here. This is a different. This one, the V1 is in the front. This one, the V2 in the front. As an encoder interface circuit, the signal from the disk, from the disk enter to the decode and decode with the D triggers become the signal to the countdown signal and the count up signal. Countdown and count up signal. The applications last class I have already introduced the applications, so I don't want to speak here. And you can read by yourself. Next, velocity sensor. Velocity sensors are optical and direct current tachometer. The light gives the light source gives the light to the shaft, and the shaft reflects the sensor, reflects the light to the photo detector. So one round for one light sensor, light signal. As the tachometer. A tachometer interface. The signal inputted to the ADC. Then the signal output to the is output to the computer. The computer process the signal. What
is a tachometer?
Tachometer is speed sensor.
Oh, okay.
Yeah, velocity sensors. Tachometer. Direct current tachometer. It's a direct current tachometer. Vehicle speed sensors. Vehicle speed sensor generates magnetic pulse in the form of a wave proportional to the speed of the vehicle. This power control model use the VSS frequency signal to manipulate multiple electrical subsystems in a vehicle, such as fuel injection, ignition, cruise control, position operation, torque, and clutch lockup. And just like we use in the microcontroller, the time clock frequency the frequency signal. Next, this is acceleration sensors. Accelerations sensors. Vibration and piezoelectrical piezoelectrical. Acceleration sensors. Measurement of accelerations is important for system subject to shock and vibration seismic mass and the piezoelectrical accelerometer this accelerometer. The seismic mass type accelerometer is based on the relative motion between a mass and a supporting structure. The natural frequency of the seismic mass limits its use to no to medium frequency application. No to medium frequency application. The seismic mass is suitable for the low to medium frequency application. The piezoelectrical accelerometer, the piezo is compact and more suitable for higher frequency application. Piezoelectrical and accelerometer for high frequency. This seismic for low to medium frequency. This is a module for the vibration sensors, seismic mass. The box is a housing. There is a base in the box. And the base are fixed to the box. Fixed to the box. There is a cantilever. The strain gauge is mounted on the cantilever When the box follow the target, the seismic mass vibration follow the target This is the vibration sensors. Seismic mass. This is a piezoelectrical. And like the seismass, there is a box. And the seismic piezoelectrical crystal is fixed to the box, but the damper and the spring is connected to the crystal, this is a structure for the piezoelectrical. Accelerometer. An accelerometer is a device that measures indirect acceleration rather than measuring the coordinate acceleration. The accelerometer sees the acceleration associated with the phenomenon of weight experienced by any test mass. It is rested in the frame of reference of the accelerometer device. An accelerometer is a device that measures indirect acceleration. Indirect. Rather than measuring the coordinate acceleration, the rate of change of velocity, the accelerometer sees the acceleration associated with the phenomenon of weight. Phenomenon of the weight. Gravity. Gravity. For example, an accelerometer is rested on the surface of the Earth. Will measures an acceleration. Gravity. Due to its weight. By contrast, accelerometer in free fall or at rest in outer space will measuring zero. This is a accelerometer. Another term for the type of acceleration is that accelerometer can measure is G-force acceleration. G-force is with measuring the gravity. Accelerometers have multiple applications. In industry and science. Highly sensitive accelerometer are components of initial navigation system for aircraft and missile. Initial navigation. Accelerometers are used to detect and monitor vibration in rotating machinery. Detect and monitoring vibration. This is the application. Gyroscope. Gyroscope is a device for measuring or maintaining orientation. Based on the principles of angular momentum. Mechanically, gyroscope is a spinning wheel or a disc in which the axis is free to assume any orientation. Although its orientation does not remain fixed, it changes in response to an external torque, much less, and in a different direction than it would with the large angular momentum associated with the disk's high rate of spin and the moment of initial. Its gyroscopes spinning high with high speed. So the orientation will be kept. This is a gyroscope. Electronic microchip packed MEMS. MEMS macro electrical mechanical systems. Gyroscope devices found in a consumer electronic devices solid state ring lasers, fiber optical gyroscopes, and the extremely sensitive quantum gyroscopes. This is the application for the gyroscopes. Some cell phones have the gyroscope. Initial measurement unit, IMU. Initial measurement unit. An initial measurement unit is an electronic device that measures and report on a craft velocity, orientation, and gravitational forces. Using a combination of accelerometers and gyroscope, sometimes also magnetometer. IMU are typically used to maneuver aircraft, including unmanned aero vehicles, and spacecraft. This is IMU. Gyroscopes magnetic field sensor, accelerometer. The three sensors integrated to this board with the USB interface and PIC microcontroller. IMU are used for the flight control. Check for the dynamic height control and attitude control. The key element is IMU. Proximity sensor. Limit switches, Hall effect switches, optical, capacitive inductive ultrasonic There's different types proximity sensor proximity sensor they are used to sense the proximity of an object relative to another object. They usually provide on-off signal indicating the presence or absence of an object. Example: inductance, capacitance, photoelectric, and Hall effect. Inductance proximity sensors consist of a coil, wound, around a soft shell iron core. The inductance of the sensor change when a ferrous object is in its proximity. In its proximity, this change is converted to an voltage triggered switch. Capacitance type are similar to inductance, except the proximity of an object changes the gap and affects the capacitance. Capacitive transducer. A change in capacitance can be brought about by varying the following parameters. Change the distance between two parallel electrodes. Change the dielectrical constant. Permittivity of dielectrical medium. Change the error of the electrode. Features capacitive transducer. Capacitance transducers can be used in high humidity, high temperature, or nuclear radiated zones. They are very sensitive and have high resolution. They can be expensive and need significant signal conditioner. Need significant signal conditioners. The features can be used high humidity, high temperature, which means is a very bad environment, harsh environment. They are very sensitive and high resolution. Capacitance transducers are generally only suitable for measuring small distance. Examples of this surface example of this surface profiles sensing measurements correct grooves correct grooves This is a capacitive proximity capacitive proximity This is a structure this is a structure proximity switch this is active phase it's a target this is a target when the sensor electrode tested the target is moving target moving so the capacitance is changed capacitance is changed so the signal is transferred to the signal conditioning and the output to the instrumentation or some device It's the capacitive proximity. This is a change for the capacitive proximity sensor. For the normal capacitance, the electrode is just neck here, If we divide the electrode just like this along the different direction so we can change the electrode like this so the capacity proximity the capacitors work like this Normally, we put the electrode like this, but in the capacitive proximity, we put the electrode like this, Inductive transducer. An inductive transducer is an electronic proximity sensor which detects metallic objects without touching them. The sensor consists of the induction loop. Electrical current generates a magnetic field which collapses generating current that for typically towards zero from its initial level when the input electricity ceased when the The inductance of a loop change according to the material inside it. And since metal are much more effective inductors than other material, the presence of metal increased the current flowing through the loop. This change can be detected by sensing circuitry, which can signal to some other device, whenever metal is detected, the metal is detected. As we know, the core of inductor is the mental core. The mental core can change the inductance. Change the inductance. So if some other mental object attach access to the inductive sensor, the inductance can be changed. Inductance can be changed. The changed inductance will affect the current or voltage. The current or voltage. This is a inductance sensor. Inductance sensor. A little like the capacitive sensor. Capacitive sensor. This is a coil in the inductive sensor. Next is a oscillator. Oscillator. This is a trigger circuit. Circuit. So the trigger circuit is triggered by the signal from the coil. So the triggered signal output to the device. It's the inductive proximity sensor. Inductive proximity sensor. Oscillator stage. Demodulator. Trigger stage. Output stage. Put this together. We get the inductance proximity sensor. Capacitive and inductive. Capacitive and inductive proximity sensors are similar in size, sharp, and concept to inductive proximity sensors. The main difference between the two types is that capacitive proximity sensors produce electrostatic field instead of an electromagnetic field. Capacitive proximity sensor produce an electrostatic field. Capacitive sensing is suitable for detecting metals, non-metals, solids, and liquids. Inductive sensing is best suitable for mechanical target mechanical target because it's both a reliable and more affordable technology Applications include detecting mental caps on soda bottles detect the mental caps on soda bottles Here, capacitive will not work because it will detect the glass bottle as well. If we want to only detect the caps, we use the inductive sensor, inductive sensing. Hello. Hello, everyone.
Hello.
Let's have
Hello,
a break.
We're hearing you. All
Hello.
right, let's see. Okay, let's have a break.
Let's have a break.
Okay. Okay, for how many minutes? Can you please tell us?
Almost
For how
20.
long to do?
Yeah.
20 minutes.
Is it 20 minutes? Then we'll start from 3:20.
Hello. Hello, everyone.
Hello, 老师。
Yes, 老师。
Let's continue our class.
OK， 老师。OK， 老师。
Last class introduced the proximity sensor. Proximity sensor. The difference between capacitive and inductive. Capacitive is suitable for menstrual, non-menstrual solids, liquids. The inductive sensors is best suitable for menstrual target. Proximity sensors, photoelectrical sensors, are normally aligned with an infrared light source. The proximity of a moving object interrupts the light beam, causing the voltage never to change. Hall effect. For Hall effect, voltage is produced and current carrying conductor. When a current carrying conductor is exposed to a transverse magnetic field, the voltage is proportional to transverse distance between the Hall effect sensor and an object in its proximity. Photo detector, the light source. When the object move along this direction, the light source is cannot pass, cannot detect by the photo detector. So the voltage change. This is the application for the photo detector. This is a floppy disk. There is a hole in the floppy disk. With the light throughout the hole, the photo detector detects the light. So the floppy is in read-only model. It's a application for the photo detector. Optical slotted coupler. When there is a snort, when the light pass to this other side, the light is detected. When something or some object pass through the snort, the voltage is changed. Hall effect. Hall effect transducers are used to measure position, displacement, level and flow. They can be used as an analog motion sensing device as well as digital device. The Hall effect occurred when a strip of conducting material carries current in the presence of a transverse magnetic field. Hall sensors utilize semiconductor Hall chips and a magnetism mounted to a shaft or a push pod. As the chip changes their output in response to the proximity of the magnetic field. Change in its position can be measured. Principle of operation. An external voltage source is used to establish a current. In the semiconductor crystal, the output voltage is sensed across the side of the crystal, perpendicular to the current direction. When a magnetic field is brought near, the negative charge are deflected to one side, producing a voltage. The output voltage is calculated by this equation. This K is constant, dependent on material. The I is a current. B is a magnetic flux density. D is a thickness constant. Hall effect proximity sensor is a principal structure magnetic. This is a Hall element. When the current flow through the Hall, the voltage contest between the side. As a Hall effect proximity. When the motion is moved like this, move along this direction, the change the magnetic field, and the output is changed. When the move along this direction, also change the magnetic field on the Hall element. Range sensors are ultrasonic range sensors. Ultrasonic proximity sensors are used as transducer to send and receive high frequency sound signals. When a target enters the beam of the sound, is reflected back to the switch, causing it to energize or de-energize the output circuit, ultrasonic, ultrasonic. S is the control circuit, control the transmitter, send signal ultrasonic to the target. Then the ultrasonic is reflected back to the receiver. So the distance it can calculated by this equation. Ultrasonic sensor. Ultrasonic sensor. This is a blocker range, operating range, and in the ultrasonic can measure the distance between in the operating range. If the distance is too close or too far, the sensing is the sensing is difficult. It's difficult. This is a sensor, range sensor, laser, range sensor, laser. The principle is like the ultrasonic, is like the ultrasonic. This is the equation for the calculation. Proximity sensor comparison. Proximity sensor comparison. Inductive, capacitive, photoelectrical, ultrasonic, The inductive sensing range 4 to 40 millimeter. Capacitive the sensing range 3 to 60 millimeter. 3 to 60 millimeter. Photoelectrical 1 millimeter to 6 millimeter. 6 millimeter. Ultrasonic 6 to 600 centimeter. This is a sensing range. Sensor range. This sensors for the short distance. Ultrasonic is for long distance. Application inductive close range detection of ferrous material. Capacitive close range non-ferrous material. Photoelectrical long range. Small or large target detection. Ultrasonic long range detection of targets with difficult surface properties. Color reflectivity insensitive. This is the application for the different proximity sensor. Target material, fluid material, most of material is okay. This is a photoelectric, silicon, plastic, paper, metal, photoelectric. The ultrasonic, cellophane, foam, glass, liquid, powder. This is a comparison between optical and laser. Optical and laser. The optical detectable target. The detection is affected by target material, by target material and colors. Ultrasonic is unaffected by target. The detecting distance, the optical 1,000 millimeter max, 1,000 millimeter. The ultrasonic 10 meter, 10 meter max, 10 meter max. Accuracy, optical is high, ultrasonic is low. The response speed, optical is fast, ultrasonic is slow. And the dust and the water can affect the optical sensor, but affect ultrasonic. Measuring range, optical is small, ultrasonic is large. Ultrasonic is large. Next, light sensor. Light sensor. Light sensor. Light intensity. Intensity and the field and region. Full field region are two important measurements used in many control applications. Photo transistor, photoresist, and photodiodes are some of more common type of light intensity sensor. Light intensity. When the photoresist is exposed to light, its resistance drops in proportion to the intensity of light. Proportion to the intensity of light. When interfaced with a circuit and balanced, the change in light, intensity will show up as change in voltage. These sensors are simple, reliable, and cheap, used widely for measuring light intensity. Measuring light intensity. As a light sensors, photoresist, photodiode, phototransistor, voltaic cell. Next, node sensor. Node sensor. Node sensor are bounded well strain gauge. Strain gauge. Strain gauge. Gauge. Strain gauge. Semiconductor force strain gauge. Low force sensor.
Where should be? Cushion? Yeah. For what? Where should be? I don't know. Yeah, this one.
Your mic. Your mic.
The bottom tube. The panel. Semiconductor pressure sensor. Semiconductor pressure sensor. The node include force, torque, and the pressure sensor. The node. Node sensor. Node sensor. The node include the force, torque, and the pressure sensor. Common force, torque sensor are strain gauge. And piezoelectrical. Piezoelectrical. Both are available to measure force and or torque either in one axis or multiple axes. This strain gauge make use of mechanical members that experience elastic deflection when loaded. These types of sensors are limited by their natural frequency. The strain gauge make use of mechanical members that experience elastic deflection when loaded. The piezoelectrical sensors are particularly suitable for dynamical loadings in a wide range of frequency. They provide high stiffness, high resolution over a wide measurement range, and are compact. The strain gauge strain gauges are limited by their natural frequency. Piezoelectrical sensors are suitable for high frequency. Very wide range frequency. Very wide frequency. This is a strain gauge. Put the strain gauge on this structure. When the force is loaded to this structure, we can get the different resist. Get the different resist. This is a strain gauge. The signal to here. Then the signal is amplified. This is a electrical bridge. It's electric bridge is balanced. Is balanced. If the strain gauge is changed, so the outputs are the voltage is output to the amplifier. Then use the AD convert convert the voltage to the digital signal and output to the microcontroller. A string gauge, a string gauge. This is a placement of a gauge. Put like this and this and this. This output is to the output to the bridge. Interface circuit use a bridge. The bridge output amplify the signal. And to the microcontroller. It's a strain gauge. Node cells. Node cells use the strain gauge. To check the node. Push on the top. This is binocular gauge. Binocular strain gauge. The strain gauge is put on here. Here. When the node is applied to this top, so this the strain gauge is deflected. So the resistance is changed. Resistance changed. It's node cell. Binocular strain gauge. Binocular strain gauge. Strain gauge features. Strain gauge features. A high gauge factor increase its sensitivity and cause a large change in resistance for a particular strain. High resistance of strain gauge minimize the effect of resistance variation in the signal processing circuit. Choose gauge characteristic such that resistance is a linear function of strain. Linear function of strain. For dynamical measurements, the linearity should be maintained over the designed frequency range. No temperature coefficient and the absence of the hysteresis. Hysteresis effect add to the precision. No hysteresis effects and no temperature coefficient. Its features about the strain gauge. Application. Strain gauge transducers are used for measuring strain, force, torque, pressure, and vibration. In some application, strain gauge are used as a primary or secondary sensor in combination with other sensors. Strain gauge. This is a pressure sensor. These are the pressure sensor. The bottom and the bellows. Bottom and the bellows. This is the bottom. Test the pressure with elastic force. Bottom. The bellow test the pressure. Test the pressure with the balance between the elastic force on the balance balance. Semiconductor pressure sensor. Semiconductor use the piezoresistive. If you give pressure on the element, the resistance is changed. Resistance is changed. Piezoresistive elements. Next, temperature sensor. Temperature sensor. Temperature sensor by mechanical temperature sensors. Thermocouples. Resistance temperature detectors. Thermistor. IC temperature sensors. IC temperature sensors. Temperature sensors. Temperature measurement is based on one of the following principles. Contact voltage. Contact voltage between two dissimilar metals. Changed in electrical resistance. Change in radiated energy. Following these principles. The most common temperature sensors are thermocouple, thermistor, resistance temperature detector, IC temperature sensors, and infrared types. Next, I introduce one by one. Thermocouples. Thermocouples are the most versatile inexpensive and have a wide range. Up to 1,200 centigrade. A thermocouple simply consists of two dissimilar metals metals-wise joined at the end to create the sensing junction. When used in conjunction with a reference junction, the temperature difference between the reference junction and the actual temperature shows up as a voltage potential. The thermal couple two dissimilar wires are connected at the end. Joined at the end. The thermal couple chart from this figure, we can see the different metal, has a different output. Different outputs follow the temperature. This is aero Constantin. This is chromium and aluminum. This is platinum and platinum are different. Thermal coupled has a different output. Standard thermal couple characteristic different material. Has a different operating range. And accuracy. Temperature sensor. The resistant temperature detector use the phenomenon that is resistant of a mental change with temperature. They are linear over a wide range and most stable. Resistance temperature detector. Semester are semiconductor devices whose resistance change as the temperature change. They are good for very high sensitivity measurements in a limited range. Of up to 100 centigrade. The relationship between the temperature and the resistance is non-linear. Infrared type of sensor, use the radiation hedge to sense the temperature from a distance. Radiation hedge. This non-contact sensor can also be used to sense a field of vision to generate a similar map of surface. LTD temperature detector is a length of Y whose resistance is a function of temperature. It consists of a Y that is wound in the shape of a coil to achieve small size and improve semiconductivity. Consists a Y is wound in the shape of a coil to achieve small size and improve conductivity. Semester operation relies on principles of change in semiconductor resistance with change in temperature. This is curves. This line shows the relation between the temperature and the resistance is non-linear. IC temperature sensor. IC is temperature sensor. Integrate the temperature to one chip. LM35. LM35 is a IC chip. IC chip. This is a comparison about the temperature sensor. From the range, accuracy, cost, and robustness. Semi-copper cost is low, robust is very high, but the accuracy is not high. LTD, the cost is medium, robust is high, but the accuracy is high. Semester cost low, robust medium, accuracy is high. IC integrated circuit. Cost no, robust no, but accuracy is no. Also no. In general, use a thermocouple when high temperature is expected. High temperature use thermocouple. Use thermocouple or RTD for process control application. Use semester or IC for motion control application. This is these are the comparisons between the temperature sensors between sensors. Hello. Hello, everyone.
Hello,
Hello,
老师。
Yes, 老师。
Let's have a break.
Yeah, 老师。
OK，老师。
Okay, let's have a
Thank you.
break.
OK，老师。OK。
Hello, everyone.
Hello, 老师。
Hello,
Let's
Lao Shi.
continue our class.
Hello, 老师。
Okay.
Yes, 老师。
Let's I will introduce the flow sensor. Flow sensor for the liquid. Flow sensor. Flow sensors are ultrasonic flow meter. Measuring fluid viscosity by passing high frequencies sound waves through fluid. Transmitters provide the sound signal source as the wave travels towards the receivers. Its viscosity is influenced by the velocity of the fluid flow due to the Doppler effect. Doppler effect. Doppler effect. The mechanical movement can influence the frequency. Influence the frequency. The control circuit compels the time to interpret the flow rate. This can be used for very high flow rates and can also be used for both upstream and downstream flow. The other advantage is that it can be used for corrosive fluids. Fluids with abrasive particles. As it is non-contact sensor. Orifice planes and Venturi flow is the orifice plates. There is two hole in the hole in the tube and the flow the tube flow. It's for detect the fluid flow. It's turbine and magnetic turbine. It's Hall effect sensor detect the turbine rotation detect the turbine rotation. S is a magnetic when the fluid flow through the tube the fluid can influence the magnetic field. Ultrasonic flow sensor. Ultrasonic flow meter measure flow velocity by passing high frequency sound waves through the fluid. They operate by measuring the transmission time difference of an ultrasonic beam passed through a homogeneous fluid contained in a pipe. at both an upstream and downstream location downstream location flow sensor for solid flow sensor for solid this is flow sensor for solid waiting platform waiting platform when the solid is moved along this belt the flow rate can be calculated by this equation W is weight of material on section of which L R is conveyor velocity L are length of waiting platform Q solid flow level sensors are used to measure the fluid level in tanks there are discrete and continuous level sensor this direct level sensor float and switch float switch when the level is high the switch is triggered by this cam this is a photo sensor when the level is higher than this position in this position and the light beam is interrupted it's a resistance probe when the the level is higher than this position the resistance become very low it's a describe the level sensor this level sensor continuous level sensor the float is become higher follow the level so the port changes its resistance with the rotation this sensing pressure head when the pressure sensor changes the output follow the level when the level is high the pressure is high this is a load sensor waiting tanks load sensor waiting tanks it's a electrode measure measure it's ultrasonic range ultrasonic when the level is high the distance is short next I introduce the smart sensor smart sensor combine the sensing elements with the microprocessor capabilities that provide embedded intelligence. Embedded intelligence. So we call the smart sensor. With microprocessor. Last semester, we have learned the mechanical controller, microcontroller. So we can combine the microcontroller into the board with sensor. So make the sensor become smart sensor. Advantage include fast signal processing, high signal to noise ratio, self-detection, auto calibration, failure prevention. With the microcontroller, microprocessor, the smart sensor can process signal, and filter the noise, self-testing, auto calibration, and prevent failure. Smart sensors have evolved from large size discrete components to small integrated sensor systems. Large size discrete components and small integrated sensory systems. It's phase 1. Sensor chip and discrete components interface to a PC demonstrates feasibility. At phase 2, integrated smart sensor chip. This is a discrete component. Power in and compensated signal out is the foundation for commercial product. Smart material sensors. New smart materials are being used as a sensor. Example optical fibers, piezoelectrical and magnetostrictive material. This is a new smart material. This new smart material. This optical fiber can be used to sense strain, liquid level, force, temperature with very high resolution. They have found numerous applications in smart structural applications, such as image sensor, vibration sensor, and Q monitoring sensor. The basic principle of operation of an embedded optical fiber used to sense displacement, force, temperature, the relative change in the transmitted intensity or spectrums is proportional to the change in the sensed parameter. The relative change in transmitted intensity or spectrum is proportional to a change in the sensed parameters. This is a principle for the smart material sensor. This is a fiber optical cable structure construction. We use the optical fiber sensor in the measuring in blood, or check the inside of the body. Check the inside of the body. Piezoelectrical transducer. Piezoelectrical material, when subjected to mechanical force or stress and non-specific planes, generate electrical charge. Give the force, generate electrical charge. The best known natural material is quartz crystal. Natural material. The racially salt, also considered a natural piezoelectric material. This is the construction for the piezoelectrical transducer. Give the force on the top and the bottom. The voltage will be produced, generated on the between the two planes. Piezoelectrical transducer. This is a construction. This is a product for the piezo transducer. Micro sensors. Micro electromechanical systems is a class of systems that are physically small. These systems have both electrical and mechanical parts, many parts, as an integrated circuit. They include macro sensors and macro actuators. Macro sensors are the miniaturized version of the conventional macro sensor with improved performance and reduced cost. Silicon micro machining technology has helped the development of many micro sensors and continue to be one of the most active research and develop topic in this area. the most active research. Macro and nano sensors. Macro and nano sensors. Macro sensors have found application in medical technology. Fibers group approximate only 0.2 millimeter in diameter has been developed to inspect flow inside tube. Fibers group. A macro tactiles macro tactiles sensor which use laser light to detect the contact between catheter and the inner wall of blood vessels during insertion that has sensitivity in the range of 1 millinewton. Similarly, the progress made in the area of nanotechnology has fueled the development of nano sensors. These are relatively new sensors that take one step further in the direction of miniaturization and are expected to open new avenue for sensing applications. Nano sensors. Transducer classification. Potentiometer. Potentiometric transducer applies the principle of change in resistance of material in the sensor. Capacitance transducer applies the principle of capacitance variation between a set of plate assemblies. Inductance transducers are based on the principle of variation of inductance by the insertion of core material into an inductor. Inductance variation serves as a measure of displacement. Piezoelectric transducers are based on the principle of charge generation. Whenever certain piezoelectric crystals are subjected to mechanical motion, an electrical voltage is induced. This effect can be reversed by applying an electrical voltage and deforming the crystal. Next, introduce the signal conditioning. As we know, the sensors produce the signal, but the signal is maybe is not suitable for the processing. So we need conditioning the signal and made it suitable for PC or microcontroller microprocessor. Signal conditioning circuits improves the quality of signal generated by transducer before they are converted into digital signals by the PC's data acquisitions hardware. This physical system and the phenomenon is censored by the transducer or sensor. The signal has a noise. So after the conditioning, the signal become clean. Clean. Filtering and amplify measure signal from the sensor. Signal conditioning include the signal conditioner accepts the electrical output of the transducer and transmits the signal to the comparator in a form compatible with the reference input. The functions of a signal conditioner include amplification, isolation, sampling, noise elimination, linearization, span and reference shift, mass manipulation, signal conversion, buffering, digitize, filtering, impedance matching, wave shaping, phase shifting, This is a function for the signal conditioner. The function mass manipulation include differentiation, division, integration, multiplication, root finding, squaring, subtraction, and summation. The signal conversion include DC AC conversion, DC AC conversion, AC DC frequency voltage, voltage frequency, digital analog, analog digital. This DA and ADR conversion, DA and conversion. The signal conditioning maybe include, maybe not maybe doesn't include all these functions, but mostly we have the filtering and amplification. In a digital control system, many of these signal conditioning functions listed here can also be accomplished by software. Filtering. Electronic filters are circuits which perform signal processing of functions, specifically to eliminate unwanted frequency, eliminate unwanted frequency and or enhance wanted frequency, enhance wanted frequency. This is a low pass filter. When the frequency is lower than this point, the frequency can pass through the filter. This is a high pass frequency. This is a band pass frequency. This is band block. Notch filter. Notch filter. This is an example for no pass filtering. No pass filtering. This is RC network. RC circuit. RC circuit. This is a transfer function for this RC circuit. RC circuit. This circuit can let the no frequency signal pass, but block high frequency signal. Amplification expands the range of the transducer signal so that they match the input range of the AD converter. For example, an X10 amplifier maps the transducer signals which range from 0 to 1 voltage into the range 0 to 10 voltage before they go into AD converter. AD converter. This is an example for the inverting amplifier. Inverting amplifier. After the signal is amplified, the symbol become the symbol is inverted. The symbol is inverted. This is a equation for the way out and the way in. This is the way in. This is the way out. If the signal passes through this circuit, the signal from the plus to the minus change to the minus. And if RF is equal to RI, this RF is equal to RI, the way out is equal to the way in, but the symbol, the sign is different. The sign is different. If the RF is bigger than the RI, so the way out is bigger than way in. Is way in. Loading effect. Loading effect. When the signal transfer along the wire, the voltage is drop. Voltage drop. Signal experience voltage drop. Experience a voltage drop. So this is 5 voltage. 5 voltage. When the signal passes through this well to here, maybe there is 0.5 4, 5 voltage drops on the wells. We call the noding effects. Noding effects. Preventing loading. Preventing loading. If we want to preventing loading, we use this circuit. This circuit. This circuit just keep the voltage. Keep the voltage. We call it the voltage follows. Voltage follower used to repeat a signal without loading down the sensor. Loading down the sensor. R in is equal to R out. R in is equal to R out. This is a voltage follower. It's a difference amplifier. Difference amplifier. Out voltage is calculated by this equation. If VB equal to VA, the V out is 0. So if you give the same signal to VA and to VB, there is no out. There is no out. So when the signal transfer by same well, the noise added on the well can be subtract here. Hello everyone.
Hello, 老师。
Hello, 老师。
I want to finish today's class. Is that okay?
Okay.
OK，老师。
Okay. We finished today's class.
Oh, okay,
Okay,
Laoshi.
thank you, 老师。
You are dismissed.